All right, we're going to do a video for example number 3 in section 6.4 now. We're going to do A and B because they look a little bit different. It is still asking us to add or subtract these rational expressions, so we still need to follow the same steps. So let's factor, get a common denominator before we can add or subtract them together. Looking at A and looking at those denominators, they look really close to being common denominators. The first one is a positive 8a and the second one is a negative 8a. They're really close to the same, but not exactly the same. What is the first one missing that the other one has? A negative, right? Or really, can I take this 8a and multiply it by a negative 1 so that it turns into a negative 8a, just like the second fraction? Once I do that, he'll have a common denominator. Making sure you multiply both the top and the bottom by negative 1, you end up getting a negative 3 over negative 8a. And then the second fraction is a 1 over negative 8a, and now I have a common denominator. Since I have a common denominator, remember I should be able to smush these two fractions together, add them, keeping your common denominator, and then just combining your numerator. So what's negative 3 plus 1? You should get negative 2, right? Now you notice that there's one term on top and one term on bottom. And if there's a common factor that you can reduce, then let's reduce it. Can't I divide both the top and the bottom, both those terms, by negative 2? When I divide both of those terms by negative 2 divided by negative 2 is 1, and negative 2 divided by negative 8 is positive 4. And don't forget there's an a there. So my final reduced answer turns into a positive 1 over 4a. All right, let's do B. If you look really carefully at the denominators on this one, they look really close to the same thing, but they're not exactly the same thing yet. This first denominator is an x minus 7, but the second denominator is a 7 minus x, and it's not exactly the same thing. If I were to rewrite this in a different order, wouldn't it be actually a negative x plus 7, which isn't quite the same thing as an x minus 7? But what if I took that denominator and I factored out a negative 1? If I did that, then wouldn't I have left an x minus 7? So really, this second denominator is a negative 1 times an x minus 7. Now it looks close to the first one, but what is the first one missing that the second one has? It has missing that negative 1 factor, right? So if I can multiply this by negative 1, top and bottom, now they have the same denominator, don't they? That means my first fraction turns into a, what did I do here? Oh, I just rewrote it in a different form. So if I give it a negative 1, multiply by top and bottom by negative 1, and then my second fraction looks like this. My first fraction has a negative 5x in the numerator minus a 3x. So that's my numerator. And then I can combine them, remember, into the same common denominator. All right. Here we go. It looks like those top terms are like terms. The negative 5x and the negative 3x really can be combined into a negative 8x, right? And it looks like I can divide each of these terms, these two negatives, can make me a positive. I can divide both of them by a negative 1, can't I? They're not connected with the plus or minus sign. So it looks like I can reduce my answer into a positive 8x over an x minus 7. All right, maybe some of you saw this or saw this, and these two negatives could make a positive, and then you would end up getting the same answer without having to worry about that negative in the first fraction. You can try it that way if you'd like, but you should still end up getting the same answer, a positive 8x in the numerator and an x minus 7 in the denominator. Nothing else can be factored, so it looks like that's our final answer for that one. So those ones were a little bit different because all they were missing was a factor of a negative 1. But it does change the problem a little bit, so make sure that you practice a couple of those.